أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Welcome to the IMRAN Academy. I am discussing with you mathematics of second year, and the chapter's name is integration, chapter number 3, exercise 3.8. And let's start the questions right away. So here we have a question. This is the question in front of you. In this question, we want to just solve this differential equation and remove the differential sign. So first of all, this is the question in front of you. What we want to do here is to solve this differential equation by separable variable form. So all variables that can be separated are taken to their respective sides. For example, 1 plus y can be divided here, and this x and dx can be taken to the other side. This is dividing here, it will multiply on the other side, and this x is multiplying to this one, and it will be dividing on the other side. Now I can take the integral of these equations, integrating both sides. You can write it as integrating both sides like this. And as you know, when we have a function in the denominator and its derivative is given in the numerator like this, the integration of this function is just log of x, fx, log of the function. So I can just apply this formula here. So it will become log of 1 plus y plus log of x equals log of x plus c constant of integration, and instead of writing it just c, I can write it as log of c. So by the property of logarithm, I can write these two numbers as x and c, or cx, and here I have log 1 plus y. Okay, if I take anti-log on both sides, the answer is this one. Log and anti-log cancels out, so y is equal to cx minus 1, which was my requirement, and this is the equation that was given in the question that I really needed to prove. That is y equals cx minus 1. So the question was, check that each of the following equations written against the differential equation is its solution. So exactly the same equation has been generated here, so I can say that yes, the given equation is the solution to the given differential equation. Differential equation. So the technique that is used here is separable variable form technique. Let's move to the next one and see what is installed in it. Okay, this is the question and this is the answer. Let's see, this question yields the same answer as given against the equation, differential equation. Let's start. Okay, so if I just take this negative 1 to the other side, I can write this as 1. Then 2y plus 1 into dy is equal to 1 over x square into dx. Now integrating both sides, I can just integrate on both sides. Take the integration sign, like this, and integrate. And what is the integration of 2y? 2y dy. Let's separate this whole thing. X raised to power minus 2 into dx. Now let's do the integration part as well. So here I can apply the power formula, power rule for integration. Okay. So it becomes 2y square over 2 plus y equals x raised to power minus 1 over minus 1 plus c. So y square plus y equals minus 1 over x plus c, and if I just arrange the terms, so I get this answer, and this was the answer given in front against the differential equation. Y square plus y equals c minus 1 over x. This is y square plus y equals c minus 1 over x. So that's how these questions are to be solved.